So let's start building our very first React Native app, just like that. Now, throughout the course, I'm gonna keep referencing the React Native docs because I don't wanna just teach you things that you only learn by looking at what we do as instructors, but I wanna show you the process so that after you're done with the course, you know how to go off on your own. Because at the end of the day, the best resources are right here on the React Native docs. What we try to teach you is the process of what are the best practices? How do we learn these things? How do we find out about things that maybe we're confused about? So you're gonna see us use the React Native docs constantly because that is the process that we use when we build React Native apps. So the first thing is when we go to introduction, if you scroll all the way down, there's an interactive example section, which I'll link to. Now in here, even if you've never seen React Native code or even React code, don't worry, just see if you can follow along. All we're going to do is click on this little icon over here. And this is going to open up a new tab where we have some code, an interactive online code editor that we can use. And this is our app over here to the right that says, try editing me. Nothing too crazy. You see here that we also have the web version. So right now I'm just seeing it on my Chrome browser, but I can also do Android. I can do iOS and emulate it. So if I do tap to play on iOS, sometimes you might get this prompt. Now, because this is a free service, sometimes you get placed in a queue that is a lineup where other people are using it, so you just have to wait your turn, which takes a bit of time. Or you can just say run on your device and it actually gives you a QR code to run on your phone. Now, we're gonna get into this a little bit later on because in order for this to work on your phone, you're gonna need to download something called the Expo app, which we're gonna talk about. We're gonna run through how to download that through the Google Play Store and also for the App Store. But for now, because we're just getting started, we're gonna just stick with the web. And just to see that we can code anything we want in here, let's just write a nice hello message in here. If I save, you see that my app now says, hello, congratulations, that's your very first React Native app. But Bruno's not gonna be impressed with this. This is pretty basic. But what I wanna do is talk about the principles, the building blocks of React Native, so we actually understand what this code does, whether you know React or not. We can actually understand what the building blocks are of React Native. Now, in the React Native docs, the second part after the introduction is this idea of core components and native components. Because if you remember, what React Native does is compile whatever code we write into native views. What do I mean by that? You see, in Android and iOS, a view is the building block of UI, or of the user interface. That is, these rectangular elements on the screen, whether it's an image, a nav bar, a title, a text, all of these are called views. A line of text is a view, a button is a view, a list is a view. A view can contain a view. For example, here, this big thing is a view that contains another view that contains this view, as you can see over here. And that's how you can think about native development. You're just building these rectangles all over the place. If we scroll all the way down over here, we see that React Native has something called core components. And what core components are these building blocks that React Native gives us. You see over here that we have view, text, image, scroll view, and text input. What React Native does is it allows us to use these components. As you can see in our code here, we're using view and text, and we're importing it from the React Native library. And React Native automatically converts these into native Android view, which is called view group. iOS, it's UI view. The text will become a text view in Android and a UI text view in iOS. So React Native inside the hood is actually converting it, compiling this into a native view so that it's performant. That's what React Native is. It lets you build your own components for Android and iOS to build those rectangular boxes of view. And these rectangular boxes of view is right here. A view is wrapped, and inside of it is a text, and there's the text. That's a view. So React Native gives us two things. It gives us the components we can use right here. And you can see here we have basic components like view, text, text input, and image that we can use. It has user interface. So if you go to user interface, we have things like switch and button that we can use. We have list views that we can use. And then we also have iOS and Android specific components like action sheets, like back handler, because on Android you have the back button. And then you have some other ones like alert dimensions. So React Native gives us these components, plus it gives us something called APIs. These are tools that we can use inside of React Native. For example, let's say I want to figure out the dimensions of a user's phone. It gives us the dimensions API so that we can measure the dimensions of a phone. That's it. React Native, all it does, it gives us these components and the APIs. And that's why when we go to our code here, we see that from React Native, we're simply importing a text component and a view component. So if we go back and review, what we've learned is that React Native, the library and the framework, gives us a bunch of components that we can use. And these components are compiled to native code both on iOS and Android, depending on what phone we're using, so that they're super performant and fast. And it also gives us APIs. That is, it gives us information that we can interact with about the phone, like phone dimensions. And you saw on the documentation that there's two tabs, components and API. And those are the tools that we get to use to build our apps. And here's the exciting part. We have these two things from React Native, but then we need another piece. And this other piece is this famous library, React. And in this course, there's going to be a path for you to take if you're brand new to React so you can get caught up. So don't worry, we'll get into that. But because React Native only gives us the components and the APIs, we then use the React library to then know what to display on our phones. What do I mean? You see here that we also import the React library, because without the React library, React Native doesn't know React-specific things. For example, later on, we're going to use concepts like state and props and React components. That isn't necessarily JavaScript. They're React-specific. And we need this library in order for us to combine all these things into a view. Now, we'll dive deeper into that later on in the course, but that's the building block. The building block is that we need React and React Native for us to display the views that we want. And if we go back to the docs and go to core components and native components, at the very bottom, there's a really good diagram that shows us the entire idea behind React Native. That is, React Native gives you a bunch of components, which are called core components. It also has something called community components. So people can build these components and share them. For example, there's a native directory to find out at reactnative.directory to see what other people have built. So you can use these native components that you want from the outside world. There's your own native components that you can build. And then there's this idea of React components. And the React components is something that, again, you'll build yourself. In our case, in our snack, this your app is our own component that we'll be building. Again, if you're new to React, don't get too overwhelmed because we'll go through this as well. But just through this, you've learned something important that we're going to do throughout the course. We're going to follow a simple 4-step process as we build out our UI. We're going to be writing JavaScript code with the React library to essentially do 4 things. One is we usually import the tools that we need. So we import React, and then we import whatever React Native components or APIs that we need. We then create our own components. Let's call this one 0 to Mastery. And this 0 to Mastery will have some views, it'll have some style, and it'll have some text. And then we usually can do some fun things like creating styles for our component. And this style sheet is an API that React Native gives us. So we can import that right over here and import style sheet to create styles. And this styles now, instead of writing it in line like this, we might be able to write it like so. So the steps are import whatever tools we need, create our components, add our styles, and then finally we export this component so we can use it in other parts of the app. Remember what I said, rectangles and rectangles, it's all views. We're just building out these views so that in the end it looks like a screen on the phone. So to finish off, go and play around with this online REPL. See if you can look at some of the core components and modify some of these things to display. I think this is really, really important. Oftentimes when we learn a new tool, it all seems like magic underneath the hood, and you don't really understand what's going on. You code along, you follow the examples, but how it actually works is hard to understand. So in order for us to really become React Native experts, and also for you to be able to go off after this course and build your own React Native apps, I really think it's important for us to understand how it works underneath the hood. And I know we're all getting excited to code, but this is really, really important. Once you learn it, then you know it and there's no more magic. So let's talk about that. We've learned that we have our React Native library or framework that gives us components and gives us APIs to work with both Android and iOS phones. We also use the React library to be able to render those views, to display those views on mobile. But there's a few other things that I want to talk about. Throughout the course, we're going to be writing this React Native code into JavaScript files, different components. But what happens when we actually run things on our phone? Well, I want you to think of it as 2 parts. One is the view layer. Now, that doesn't mean it's just always React, but there's always those native views that we talked about. Those views that get converted from something we wrote in React Native to a native view so that it's really, really performant. Things like view and text input are all things that we can use, we can write in React Native, and then gets compiled down to native code. The second part of our code is the logic, right? We have the views, but then there's different logic that happens, such as when a user clicks on a text input, when a user uploads an image or takes a photo, what happens? There's also logic with our code. So we have views and logic that goes along with that, which is obviously written in JavaScript. So the first step is that React Native compiles our views into native views, which is really, really performant. It's what makes React Native better than hybrid apps like Cordova or Ionic. But then the second part is that it needs to understand this JavaScript logic on the phone. Remember that the phone understands Objective-C, Swift, Java, or Kotlin, but doesn't really have a concept of JavaScript. You see, in order for React Native to work, it needs something called a JavaScript VM or virtual machine. This virtual machine has a JavaScript engine that allows it to understand this logic that we write, this JavaScript code. So most of the time, this VM is called JavaScript Core. It's a JavaScript engine that actually powers the Safari browser. So with React Native, the JavaScript core engine is used to read this logic, and then this JavaScript virtual machine communicates with the phone, with the native platform and API to tell it what to do, what actions to perform. So when we ship React Native code to a phone, we are essentially shipping this entire part. That is, we compile our views into native views, so that's really, really performant. But then we have this piece over here that is surprising to a lot of people, that we actually ship JavaScript code with a JavaScript VM that can understand it, and a way for us to communicate back and forth with the phone, telling it, hey, do this, hey, do that. I want to dive a little bit deeper into that blue part that we ship. So remember, we have our JavaScript file, we have our JavaScript core, which is the JavaScript VM or virtual machine that is able to communicate with the phone. And remember that the phone only understands Objective-C or Swift or Java or Kotlin. So what happens is we have the native platform API that the developers at Apple and developers at Google have created for their own operating systems. And then React Native has this thing called React Native Bridge. And this React Native Bridge is written in C++ and Java to communicate. So if in our JavaScript file we say, hey, do this because the user just pressed this button, then this React Native Bridge is going to say, oh, in JavaScript, this person said do this. Then it's going to talk to the native platform and say, hey, the user wants to perform this. So this idea of a bridge is actually a very common pattern in programming. It's called the message broker pattern. And it's a way for us to communicate when we're using two different languages. For example, if we want to communicate between, Python and JavaScript, we would use the message broker pattern. In this case, our JavaScript or the JavaScript thread uses JSON, a format, to message this React Native bridge. And then this bridge translates whatever that action is into, again, another format that translates to the native thread of the phone. So again, if we review, we have the views which get compiled into native views. So the phone receives the exact native code, so it's super, super performant. But it also receives this JavaScript virtual machine and the React Native bridge to communicate with the phone as the user is using the app. Now, looking at this, you might notice a clear downside to React Native. That is, no matter what, it's never going to be as performant as native development, right? Because it has to ship this virtual machine and the bridge in order to communicate with the phone. So when we start a React Native application, it first creates the main thread, that is the native thread of the phone, whether it's iOS or Android. And as soon as the application launches, it loads the app and also starts the JavaScript thread, because the instructions say, hey, because this is a React Native app, we also need to read JavaScript. So it creates a JavaScript thread to execute this JavaScript code. So when a user, let's say, touches the text input or wants to do something to interact with the app, the main thread of the phone, that is Android or iOS, says, oh, something happened, an event happened. And it tells through the bridge the JavaScript, hey, JavaScript, somebody just touched this app right over here. What should I do? And the JavaScript says, well, because Timmy over here pressed this button, display this. So the instructions and communication happens back and forth on the phone between the main thread and the JavaScript thread. So the JavaScript thread runs all our business logic inside with React Native. How cool is that? I think this is really, really interesting because now we understand how React Native apps work, but also a clear downside that we're going to have to ship this and it's going to take a little bit longer performance-wise because this communication has to constantly happen between the JavaScript world and the native platform world. You want to hear something exciting? You just learned an important concept of React Native and something that most React Native developers don't know, and that is what it actually does. You see, if we go to the React Native repo here by Facebook, because remember, React Native was created at Facebook, if we scroll down, we see what language or languages it uses. So over here, we see that it's mainly written in JavaScript. That makes sense. But there's also Java, Objective-C, C++. Why is that? You should be able to answer that question now, right? Because React Native, not only is it just JavaScript code, but it is also that bridge that allows us to communicate with the native platform. And the way we communicate with the Android platform is through Java. The way we communicate with the iOS platform is using things like Objective-C and C++. And now we're also able to uncover some interesting things about React Native and actually understand why they are the way they are. For example, if I go to the JavaScript environment section on our React Native docs, we can actually understand this. It's going to say, when using React Native, you're going to be running your JavaScript code in two environments. Okay. In most cases, React Native will use JavaScript Core, the JavaScript engine that powers Safari. We just learned that. That's great. Now, when using Chrome debugging, which we're going to do throughout the course, that is when we test our app on our computer instead of our phones, we're going to be using the JavaScript code on Chrome. So Chrome uses the V8 engine instead of JavaScript Core. So when we test our code on our browser, instead of using JavaScript Core, it's going to test using the V8 engine to understand JavaScript. So this way we don't have to ship the JavaScript Core while testing our app. Everything is really, really fast because our browsers already have this. Now the beauty is that because all our React Native apps have this JavaScript runtime or environment, it also gives us some niceties like the Babel JavaScript compiler. So this way we can use all the new JavaScript features because our code is compiled through this so that we can use arrow functions, we can use object spread, we can use things like JSX for React, and so on and so forth. But there's also some exciting things now. For example, when you go to using Hermes, this is a new feature that just came out of Facebook. Facebook was having issues with this idea that the JS core that we were running with every single React Native application was really, really slow on Android. So they came up with an open source JavaScript engine optimized for running React Native apps on Android. And this is an interesting thing. So Hermes is a new way for you to, instead of using the JavaScript core, to ship Hermes, which is optimized and faster for Android. And this was a common problem with React Native. Usually, apps on Android were slower than the apps on iOS. And that was because iOS naturally already comes with the JavaScript core. Remember, JavaScript core is used for Safari. Safari is a browser by Apple. And they include JavaScript core on all the iOS apps. Android, on the other hand, doesn't have that. So we saved a bit of space with iOS apps because they didn't need to include the JS core with React Native because it was already on the phone, versus Android that doesn't have the JS core on the phone and instead had to ship it all together with our JavaScript logic. So Hermes was created to say, hey, don't use JavaScript core because it's bloated, it's heavy, it's not as performant. Instead, use Hermes, a new JavaScript engine that is optimized for Android. How cool is that? Now, I know we geeked out a bit about the internals, but I hope things are starting to make sense. And This is kind of fun now, because when we write code now, we understand how things are working underneath the hood, how React Native is able to have native-like performance, but also use JavaScript to communicate with these phones that historically only like to be coded in a certain language. We have some fun times ahead, so let's get into it. Pause the video and think about it. Is there CSS? And CSS, hopefully everybody knows, is a way to style your web apps, your web pages. But is there CSS in React Native? Is there a way for us to style things on mobile with React Native? Ready for the answer? Technically, no. Technically, there is no CSS in React Native because remember, we're not on the web. CSS and HTML are for the web, right? React Native instead uses native mobile tools. So the CSS that we use in React Native is actually built through JavaScript. It's based on the CSS syntax, but a little bit different. For example, if we go to the style section of the React Native docs, you see that with React Native, you style your application using JavaScript, and that all core components accept a prop name style. So although they've mimicked how styles work on CSS, there's small differences like using JavaScript camel case instead of the dashes that we see with CSS properties. And we also have things like style sheet, the style sheet class that React Native gives us for us to create styles. But there's a few things like not having pixels because again, it just natively creates the views for us. So if we go to height and width, you see that it has something called fixed dimensions. All dimensions in React Native are unitless and represent density-independent pixels. Essentially a way of saying that it just figures out the best way to display things on the screen based on the screen dimensions. The other thing it does is that for layout, it uses Flexbox automatically. So although it's very, very similar to CSS, technically it's just all JavaScript because we're in the mobile world, not the web world. Hopefully you got that, and hopefully because of the previous lessons, this all makes sense.